All right, so today we're going to talk about valence electrons, and we're going to review real quick. You're going to have, make sure you know neutral atoms, okay, protons equal the electrons. Make sure you know what ions are. Protons do not equal electrons. And then remember, if it's an ion, they have to show the charge with a superscript, okay? Isotopes are two atoms that are the same atom and have different masses, okay? You remember that? And so, like a lithium-7 and a lithium-6 are isotopes of each other because they're two same atoms. Because remember, the protons define the atom, and then the masses are different, okay? But today what we're going to talk about is valence electrons. And valence electrons are the electrons in the outer energy level, okay, of the atom. And that is the things that are getting lost and gained to make ions, okay? So the valence electrons are the electrons getting lost and gained. And it's the reason why all the groups have the same properties. The things in the same group all have the same properties. So group 1 are going to have similar chemical properties. Group 2, similar chemical properties because of their valence electrons. All right, so it's actually super easy because it's in order. So group 1 has 1 valence electron. All right, group 2 is going to have 2 valence electrons. And then group 3 through 12 is going to have varying valence electrons. So you don't have to know those because I'd have to tell them to you. All right, now group 13 is going to have 3 valence electrons. You're like, well, wait a minute, it was 1, now it's, it was 1 and then 2, and now it's 13, but it only has 3. Well, remember, there's 10 transition groups, right? So just take 10 minus 13, and how many do you have? 3. Take 10 minus 14, and how many do you have? 4, okay? So boron and aluminum, that family is going to have 3 valence electrons. Carbon, 4. Nitrogen's family, 5. Oxygen's family, 6. The halogens have 7. And the noble gases have 8, except for helium that has 2. Remember, the magic number for valence electrons is 8. That's what we want. And that's why we talked about elements gaining and losing electrons in order to become stable. The non-metals, the ones over here, are all going to gain. Because if I start with 7, I only need 1, right? So if I gain 1, I have a -1 charge. If I start with 6, I only need to gain 2. So I gain 2 and I have a -2 charge. If I start with 5, I need to gain 3, then I would have a -3 charge. Carbon could go either way. You can gain 4 and it would have a -4, or you can lose 4 and it would have a +4. And then boron and aluminum are technically metalloids, okay, and they're going to have positive they're going to form positive ions because they have 3 valence electrons. So it's easier to lose 3 than it is to gain 5, okay, to have 8. And then all the metals are going to lose electrons, and that's why they form positive ions. So group 1 is going to lose the 1 it has. Group 2 is going to lose the 2 it has to form +2 ions. Now, we're going to represent the valence electrons with Lewis dot structures. All right, what is a Lewis dot? It's just a dot outside the symbol of the element to show how many valence electrons it has. And it's super easy because like group 1, all of them are going to have 1 dot. So hydrogen, 1 dot. Lithium, 1 dot. Rubidium, 1 dot, okay? And that represents its valence electron. So neutral rubidium has 1 dot. But what if I make it an ion? If you make it an ion, it's going to lose its dot. So it's going to have rubidium with no dots, and it's going to have a +1 charge. Okay, so any positive ion, those are all the metals, when they lose electrons, okay, they're going to form positive ions. So their Lewis dot structures, when they're neutral, are going to be their group number, right? So barium has 2 dots because it has 2 valence electrons, but a barium ion is going to lose its 2 dots, and it's going to have no dots and a +2. Boron's family, if it has 3, a neutral boron is going to have 3 dots. Okay, but if it's a boron ion, it's going to lose its 3 dots, and it's going to have no dots and a +3 charge. Okay, carbon's family could go either way. Remember I told you that? So if carbon has a +4, it's going to, a neutral carbon has 4 dots. A carbon +4 ion has no dots and a +4. But if it gains 4, then you're going to show it with 8 dots and a -4. So now we're getting into nonmetals, and the nonmetals are going to gain electrons in order to become stable. Okay, so nitrogen's family has 5 dots. So a neutral nitrogen has 5 dots. Okay, and its electron dot or Yeah, Lewis dot structure. But a nitrogen ion, you're going to show it with 8 dots because it gained 3, so it has 8 dots and a -3 on the outside. Oxygen's family has 6 dots in its Lewis dot structure. Remember, that's oxygen, sulfur, selenium, the whole family. They have 6. But the ion of that family is going to gain 2, so it has 8 and a -2 charge. And then the halogens have 7, so it's going to gain 1 when it makes an ion, and it's going to have 8 dots and a -1 charge. Do you guys see the trending there? Okay, so as you gain electrons, if you gain 1, you have a -1 charge, but you're going to show it with 8 dots around it. So how would they ask that test on a test question? They will say something like element Z, we'll say is in, we'll just say it's in nitrogen's family. It'll say element Z is in nitrogen's family. What would a neutral Lewis dot structure look like? Well, you'd have to draw element Z neutral with 5 dots, okay? Then it'll say, what does the ion look like? Well, it goes from a neutral atom to an ion, so now it's going to gain 3, and element Z as an ion from nitrogen's family would be 8 dots and a -3. Okay? It might say element X is in beryllium's family, so it has 2 dots as a neutral atom. What's the ion going to look like? You're going to draw an X with no dots and a +2. You see that? So like they're going to indicate, like they're not always going to give you the element symbol. They're going to tell you what family it's in so that you understand that the family all has the same Lewis structure. And then you have to make it into the ion. If it's a metal, it's going to lose its dots and have the charge on the outside. If it's a non-metal, which is the right side, it's going to gain, so it's going to have 8 dots and whatever the charge is. Okay? So you need to know the number of valence electrons and the charge for each family. I know on the periodic table over here, I have the post-its up. You will not have the post-its on the test. Okay? Now, some other things that you might want to know for the test. All right? You got to be able to do sig figs, and you got to be able to do metric conversions and calculations of sig figs. So, what if they give me, 8.63 kilometers, and they want to know how many centimeters that is? The expectation is, kilo is 1,000, hecto is 100, deca is 10, and then meter, liter, gram are the base units, and then you have deci, centi, milli, which is 1/10, 1/100th, and 1/1000. So when I do this, you set it up, write down what you're given over 1, then kilometers goes down, going to meters. Which one's bigger? A kilometer's bigger, so it gets to 1. How much bigger? Well, there's 1,000 meters in 1 kilometer, so that gets rid of kilometers. Now I'm at meters, so I get rid of meters and I'm going to centimeters. Okay, well, which one's bigger? A meter's bigger. Okay, so it gets to 1. How much bigger? 100 times bigger. So that would get rid of meters. And then you're going to multiply 8.63 times 1,000 times 100. And then the other, you got to show them in scientific notation. So you're going to get that number is going to be 86300. Okay, and then you got to put it in scientific notation. So you move the decimal to where it's 1, 2, 3, 4, 5 spaces to the left. So it's to the right of the first whole number. You keep 3 numbers because that's what I started with. So my sig figs has 3, and you put it in scientific notation. So that's a way they can test you on, do you know sig figs? Do you know how to calculate with dimensional analysis? And can you write scientific notation? It's all in one question. Okay? You guys get that? Your test is going to have I think 5 or 6 multiple choice questions, and then it's going to be a couple matching or choosing from whatever, and then there's 2 or 3 matching questions, and the rest are going to be just problems where you're filling it in. Okay, and you got to show your work. You have to show your work. All right. Now I'm not going to be here on Wednesday, so I'm just telling you right now, there's going to be a sub here, and they're going to, the test, they'll be in rows. There's 6 different versions of the test. I'm just telling you right now, don't cheat. Because if you cheat, you get a 0 and you're out of National Honor Society, and you cannot retest. You're like, well, I just, I wasn't sure, so I wrote the, kilo, whatever on my hand. If you get caught cheating, you get a 0, and there is no arguing. Do you understand? So I'm just telling you, like, I try to make it so like you can't use your own calculators. You have to use the calculators we use in class. Okay, and so you're not going to write stuff on your calculator lid. You're not going to put cheat sheets in. I mean, just telling you right now, like you, that should be a relief to you that I don't have to cheat, because I can't cheat, because if I get caught, it's going to really mess up everything. Okay, so just take that pressure off and just do your best. Just study your best and do what you can. All right. Bohr models. If you have to draw a Bohr model like you will today in the review, if it says you have, 3919 potassium, then you say, well, how many protons? You have 19. How many neutrons? Well, 39 minus 19 is 20. And then you have to fill in the proton or the electrons on the outer shell. So I have 2, 8, 8, 18. 18 are my maximum number of electrons. Well, I only have to do 19. So I have 2 in the first shell, 8 in the second, and then 8 in the third, and then 1 in the fourth. Because it's 2, 8, 8, and then plus 1 is 19. So that's how I would show a Bohr model. Okay, in today's, in today's thing, you're going to have to be able to convert 45 miles per hour into feet per second. So how do I do that? Well, you start off with 45 miles per 1 hour, and you're going to get rid of miles first. So miles goes down, and I'm going to feet. Well, you look at your conversion factor, 5,280 feet per 1 mile. That gets rid of miles, and I'm at feet. That's good. That's what I want to be done. Then I got to get rid of hours. So it's another problem, but it's part of the same thing. So if hours is on the bottom, how do I get rid of it? It's going to go on the top. So hours up, going to minutes, because I don't know how many seconds are an hour, but I know how many minutes are an hour. There's 60 minutes in 1 hour. That gets rid of hours. Now I'm at minutes, so minutes goes up to seconds, and there's 60 seconds in 1 minute. Gets rid of minutes. Now I'm at feet per second, which is what I want. And it's 45 times 5,280 divided by 60 divided by 60. And how many sig figs can I keep? 2, because I have 2 in my starting number. You see that? So that's dimensional analysis with a derived unit. Yes? You do have to know the people, okay, and what they did. So, like, you need to know, Democritus was the first guy that thought about atoms, whatever, and then, but really Dalton was the atomic theory, and he was the guy that said everything's made up of tiny indivisible particles called atoms. That was his first thing. His second thing was atoms of the same element are the same atom. His third thing was atoms of different elements are different atoms, which is super obvious. And then the last one was atoms can combine with other different atoms to make compounds. So really those things are super obvious. You just gotta know that he did it, okay? And then Thomson was the guy that disproved the indivisible particles, right? Because he found out the subatomic particle electron, because atoms are actually made up of things. They weren't the smallest particles, all right? And so that was Thomson with his cathode ray experiment, and his he discovered the electrons. And his model was called the plum pudding model. Rutherford then found the neutrons and then later the protons with his gold foil experiment, and then Chadwick did the neutrons, and Bohr is the guy that put them in fixed orbitals, and he said that electrons, he called it a planetary model, said that they're orbiting the nucleus like planets orbiting the sun. And then Schrodinger came up with the quantum model, which said that they're not in fixed orbitals, that they're actually in these sublevels and these around the nucleus, and then that's what we're going to get into next. That's the modern theory. It's the quantum theory. All right? Any question with that? Any other questions you guys have before? Yeah.
Are the instruments going to be on this?
No, there's no lab. There's actually no lab safety and no lab instruments. You can take that out. Okay? Yeah.
Wait, so a neutral atom is when the protons equals electrons?
Yes.
What is it called when the valence thing is filled?
That's a full outer shell, so that's going to be like
Stable?
a stable atom. It's a stable ion because it's going to form an ion to become like that.
Okay, for the last one, it wouldn't.
Yep. They have 8 already, so they're not going to form ions because they're already stable. So their neutral atoms are stable.
Okay.
All right. Any other questions? So test on Wednesday for you guys, and Just like I said, I also, if you go on Schoology, today you're going to do the puzzle piece, okay? And I made it so you could see the right answers, not so you can just sit there and do it. Like, I'm not stupid. Like, if you don't put, like, it's hard. Like, if I were you, I would do it the best you can and then see what you got and then correct your stuff and then go in and get 100 on the second attempt because you've done it. But it's hard. Like I said, you got to be able to do the average atomic mass problems and know what you're doing. And then there's 3 other worksheets on there that are not grades. The puzzle piece is a grade. The 3 other worksheets are just there for your practice. And there's a note there that basically tells you everything that's on the test, all the topics. So I'm trying to make it so there's no surprises. But you got to be able to do the stuff. All right? So that's what we're doing today. And then on Wednesday, you're taking your test. And then on Friday, we start the new unit. Okay? And that's going to be periodic trends. And I won't be there for that. So you're going to have to watch the video. All right? All right, y'all. Get after it on your puzzle piece.